All right, y'all, we're gonna get started. I don't have any announcements on these slides, but I can make some verbal announcements. So the Hack Challenge kickoff was today. Hopefully you found your teams. I did make an announcement in the Hack Challenge Ed discussion. So check that out if you want to look at the slides or if you want to see your teams. There's a form, a roadmap form that's due Wednesday, which you and your teammates will all need to submit. It's basically a form that you will kind of ideate your app and pitch your app idea, as well as delegating tasks for each member. And then after that, the midpoint submission is due, I believe, Monday. I know that A4 is due this upcoming Thursday, and then making that midpoint submission due Monday is a little bit short. So for iOS at least, I'm probably going to extend that to the day before Thanksgiving break, so maybe Tuesday. So extend that by 1 day. But for the midpoint submission, you just need to have multiple view controllers, or at least one kind of scrollable view. So it can be a collection view or a table view. Well, actually, after today's lecture, you won't be limited to using UIKit. There's actually another framework that I'll be teaching y'all. That's why in the submission I said scrollable view, because I didn't want to make it specific to UIKit. Okay, are there any questions about logistics? Yeah.
For the A4 midpoint, right?
Yeah.
Is it completion as in you need to complete all 3 parts to receive the 5 points? Or is it if I complete 2 parts and then half of the third, do I still get points?
Yeah, you just need to show some progress. If I see that you've made progress, I know that you're on track, even if you don't make it to that midpoint, then you're good to go.
Thank you.
Yes.
I heard from my backend teammate that there is a hacking challenge at discussion.
Yeah.
Can we have the link?
Yeah, I can actually pull it up right now. Actually. Right here. So yeah, join this ed discussion for the hack challenge stuff. Got it? Oh, yes.
For last class is on Wednesday, correct?
Yeah, so after today's lecture, Wednesday will be a continuation of today's lecture, and then after that, we won't have any lectures. I'll still take attendance. So for today's attendance, I already checked y'all off as y'all were walking in, and then I'll do the same thing on Wednesday. So don't worry about attendance if you're here. Okay. All right, so let's get started with SwiftUI. So have any of y'all heard of SwiftUI before? Yeah, quite a few of y'all. Yeah, so this actually gives me, giving this lecture gives me kind of a throwback, because last semester when I first joined App Dev, this was actually my first ever lecture. I gave a guest lecture on SwiftUI, and so this time I'm the course instructor, and I'll be giving the, guest lecture for SwiftUI again. So it's kind of nice. But anyways, let's take a look at what is SwiftUI. So SwiftUI is a declarative framework that was introduced by Apple to allow you to build your user interfaces. And it was introduced back in 2019 as a replacement for UIKit, which is the framework that y'all have been working for in the past few weeks. And SwiftUI allows you to create more concise and readable code. It's a lot easier to maintain and extend, and it is the future. So the, Vision OS, for example, making widgets, for example, right? Those are all future Apple ecosystem operating systems. And so because of that, Apple has been encouraging developers to start developing apps in SwiftUI so that you can kind of build up, think about the future. So in order to actually understand SwiftUI, there's a clear distinction that we all need to kind of understand. which is imperative versus declarative. Now, the best way to kind of understand this is to look at some kind of analogy. So I usually take this shopping cart or going to the grocery store analogy. So imperative defines how tasks should be accomplished. Let's say I want to go to a store. So what I can do is I can drive my car, go to the store, or go to Wegmans, for example, go walk down the aisle, and then look for, let's say I'm trying to look for a piece of steak, for example. I go into some aisle where the steak is at, I look for the steak that I enjoy, and then I put it in my cart, go to the checkout area, and then I check out my steak, and then I drive back home, right? So the example that I gave just there is just defining how tasks should be accomplished. I gave step-by-step instructions on how you should do things. That's how I'm going to buy a steak. Whereas the declarative approach, all you have to do is define what task should be accomplished. And the what would be buy me a piece of steak. So the declarative approach would be, okay, all you have to do is just buy a piece of steak. You don't care how you do it. I don't care the steps that you take to do it. I just want to know what you're doing. So then again, imperative defines how the task should be accomplished. Now let's take a look at some code that you're probably familiar with. So you have this view controller that contains a property storing a table view. Now, how did we initialize this table view? We have the setup table view functions in which the properties of this table view, you are kind of setting its properties to some kind of value. That's that how thing that you're doing. That's the imperative approach, right? You're saying, okay, I'm going to make the delegate equal to self. I'm going to register the cell. I'm going to set translate auto resizing mask equal to false. That's defining how you're doing things. Now look, there's even more code, right? You have to tell it, okay, what cell am I going to use, right? How am I going to do that? I'm going to give you this cell. What about the number of rows in the section, right? You're going to return users like count, for example. Now, the problem with this is that there's way too much code for something that could be very simple. So let's take this into, let's shift this into the declarative approach. Now, declarative means you're defining what task should be accomplished. So it's okay if you're not familiar with SwiftUI code yet, but this right here is SwiftUI. So all of that code that I showed earlier, this is how you would write it in SwiftUI, right? So instead of telling it how to do things, instead of setting the properties to equal to some value, what I'm doing is I'm saying, give me this list, give me this navigation link, give me this navigation view, right? I'm telling it what to do. I don't care how I'm doing it, I'm telling it what to do. So now, is there more code to it? Nope, that's it, right? That's the beauty of SwiftUI. We told it what to show based on like the current state of the app. And what SwiftUI does is that it enforces the rules for us. And so let's get started with SwiftUI. So y'all don't have to follow along, or y'all can just watch me demo. But I'm going to quickly show y'all how to create an app in SwiftUI. So I already ran this beforehand because, you know, Xcode takes forever to load. But what you can do is go to File, New, Project. Now normally, well, you would click App. Now normally, you would in here select Storyboard, and then for the project name, I can put Sample. But normally you would put Storyboard. Now, what do we do additionally every time we do this? Well, because we're using programmatic auto layout, we don't want to use a storyboard. So there's like a bunch of files that you have to delete, and that's like a bunch of stuff that we don't really have to do when you're using SwiftUI. So if you want to create this app, all you have to do is select the SwiftUI interface. Click Next, and then you can select where you want to create that file. Okay, so I already created it here. So let's kind of take a look at what this code is doing. So let's look at the project navigator first. So what I did was I kind of take everything out from that code and put it on these slides. So sample app.swift contains a code that is executed at launch and is kept throughout the app's lifetime. So back in like UIKit, when you created an app in UIKit, you had an app delegate, you had a scene delegate that basically tells Swift where your app's entry is. Sample app.swift, which is the file that I created, it contains code that will be launched or that will be executed when you launch the app. Now, content view contains the code where you will put all the UI that you created. So most of the UI, most of the code that you write, that will be inside of contentview.swift. All right, now let's take a look at contentview.swift. I have a struct called contentview, conform it to this protocol called view, and then I declare a property called body with a return type of some view. And then there's also this preview thing. So what does import SwiftUI do? So just like we use import UIKit, you also need to import SwiftUI. That's basically how you tell it which frameworks we want to use. Now for this struct part, what we did is that we create a struct called content view, and you conform it to this view protocol. So anything that we draw on our screen must conform to this protocol called view. And the only required property that you have to create inside of the struct is called body. That's the name of the property. And its return type is some view. So this right here is actually known as like a computed property. Think of it as some kind of property in the struct that has some kind of computed value. Okay. I'll discuss about the actual return type of this later, but for now, it's some view. Now, what do we do inside of this property? Well, we create a text with the string hello world. So now, if we think about the declarative approach, what I'm doing is I'm saying, this is what you should be doing. You should be giving me a text with the word hello world in it. All right, that's the declarative approach. Last but not least, we have the preview. Now, this syntax is only available if you have Xcode 15. If you have an older version of Xcode, it's going to look slightly different. But basically what this preview does is that it allows you to kind of do live previewing, which is really, really, really nice to do. So you don't really have to run your app every time you're creating your UI. You can see your UI as you're coding. Okay, so, well, what do we notice about this view right here? Well, as you can see, we use a struct instead of a class. Now, back in UIKit, right? Back in UIKit, what we did was we had a UI label, we had a UI table view. Those are classes provided by the UIKit framework. Now, whenever we want to create this view, we would have to create an object of this class, provide all of its properties, set it to some value, and then we can do whatever we want with those views. But in SwiftUI's case, we don't use classes, we use structs. And as we know, structs are immutable, whereas structs are value types, whereas classes are reference types. So why does SwiftUI use structs for views? The number one reason is because structs are a lot faster than classes. And so, as we all know, structs, whenever you change one of its properties, that entire struct gets deleted and a copy of that struct gets created. Now, because that struct gets entirely deleted, it's a lot faster because you don't have to worry about keeping that same object. You can just completely trash it. That's why it's a lot faster than classes. The second reason is simplicity. So as we all know, in UIKit, you have a bunch of UI views. It could be a UI label, it could be a UI button. Those are classes. Now, every class that we create in UIKit has to be a subclass of UI view. Now, the problem is that UI view, remember, it's a parent class. So there's a bunch of properties and methods that you don't even really use, right? Imagine you have a bunch of, different properties inside of a UI view. Like, for example, in the UI label, sometimes you only want to set its text. You don't want to do anything else. But those are there for you. But the problem is that we don't really use that. So classes are they're way too intelligent, and you can change the properties very freely. And the issue with, using classes for views is that things can get really, really messy. because they're way too intelligent. What we want is that we want our views to be really dumb and simple, right? Their only job is to convert some kind of data into the UI. So for example, if I want to see a text, right, all it does is I pass in some data to it and it will give me that text. I don't want it to do anything else. It should be very, very simple. And then with structs, you can't really create a subclass of a struct. In that case, there are no inherited values. So everything you see is all of it and nothing more. If I see a text, that's what I'm seeing. I see just a text, nothing more. For example, if I want to see the text hello world on screen, I create a text object. Remember, this is a struct. I pass in hello world. If I want the image with the word or with an asset name called adaptive logo, I can just do it like this. If I want a rectangle, for example, all you have to do is just create a class or create an object of the rectangle struct and then just do it like that. The color red, for example, if I want the color red, all I do is just do color.red and it gives me the color red. So what's happening is that you're declaring what you want. Now there are a bunch of different structs provided by SwiftUI that you can kind of create, that you can kind of use to create your views. So for example, a button. If I want a button, all I have to do is just create this one button. So yeah, there are a lot more provided by SwiftUI. If you're interested, then a really helpful resource would be Hacking with Swift. That's a very, very popular resource that a lot of developers use. All right, so now earlier I mentioned like the text with the word hello world in it. Now what if we want to kind of make it look a lot better, right? What if we want it to be red? What if we want the font size to be 24, a black background, and then a padding of 20? So why not we try this, right? We create a struct and then give it these initial values in the initializer of the struct and then pass in these values. This right here is actually the incorrect way to use SwiftUI, right? Back in the UI kit, you had like, for example, a UI collection view. Whenever you initialize a UI collection view, sometimes you have to give it some kind of flow layouts. Whereas in this case, I don't pass it any value when I initialize. All I want is just some text, right? I don't care about any of these. I just want to create a text for now, right? It's not smart enough to create these properties. So how do we create a modified view? How do we create this type of text right here? We use this thing called modifiers. So modifiers are essentially just methods that you attach to your SwiftUI views. And there are a bunch of modifiers that you can use, and then you can even create your own modifier. So for example, if I have the text hello world, if I want a red text color, I do dot foreground color with dot red. If I want a font of dot title, I can just do dot font dot title. Now, you may think that, isn't this the same thing as changing the view's properties? Well, not really. Structs are immutable. When you change a property, that entire struct gets deleted. So what happens whenever we create these modifiers? Well, what's happening behind the scenes is that a new struct is actually being created. So for example, if I had this text with hello world, by doing dot foreground color, what's happening behind the scenes is a new struct is being created with this modifier. A brand new view is being created. Whereas in UIKit, if you have the UI label, if you're changing its properties, that same instance still lives. Okay, before I move on to a quick demo about modifiers, are there any questions? Yes.
Are like previous packages like Alamofire and like Snapkit?
Yeah.
Perhaps work with this? I don't know if Snapkit.
Snapkit probably won't, because later on in the demo, I'll show you kind of how you lay out your views in SwiftUI, whereas Alamofire, you can actually use it with SwiftUI, because it's more of like a native Swift wrapper library. It's not specific to SwiftUI. Yes?
If you create a project with SwiftUI instead of storyboards, do all like the stuff still work?
Okay, the cool thing about SwiftUI is that it's actually forwards and backwards compatible with UIKit. You can actually write UIKit code in SwiftUI and then wrap it inside of SwiftUI code. You can also wrap SwiftUI code and put it inside of UIKit as well.
Would it be fine if you just didn't SwiftUI at all and just,
Um,
or do you have to change it to storyboard?
that storyboard stuff actually just helps you like create that project, but to be honest, you can actually create your own files and then like call it whatever. So you can just leave, like if you want to transition to SwiftUI, you can actually still leave that stuff there. But my recommendation would be either start your app with SwiftUI or start your app with UIKits. But if you ever do need, I guess, to use one or the other, you can always just wrap it and then use it within your code. Okay, so using this sample app that I created, what I'm going to do is I'm going to create this view that I want to show. So, let's see. So I want the text red, or the text hello world, and make it red. So what I'm going to do is inside of here, I can just do text, and then I pass in a string, hello world. Okay, so you can see on the right, it actually just does it live for me, which is really, really nice. Now, I want the text color to be red. So I add a modifier, .foreground. .foreground color is actually deprecated, or it's going to be deprecated. So the new modern way to do it would be using .foreground style. I'll just use .foreground style, but the syntax will be the same thing. So I use .red. Okay, and then I want to change the fonts. So I could do .fonts. Let's say I want a font size of 24. I could use .system fonts, or .system. The size would be 24. Okay, so you can see that it gets bigger. Now I wanted a black background, so I can do .background. Inside of here, I can do .black. If I want a padding on the outside, so I want the padding or the black background to have a padding. So let me try to do .padding 20. Now you can see that padding never actually shows in the background. Like the black background doesn't have the padding. Well, the issue is, remember what's happening is that every time we're adding a modifier, SwiftUI is creating a new view. So when we're doing .background of .black, what it's doing is that it's creating a view with that black background. But then when we add .padding, it uses that same, I guess, view that we had, creates a new view, a new struct with the extra padding, which is why this thing doesn't have a black background with the padding. So to fix that, what we can do is just change the order. So now I want to have a padding, and then I want to set the padding to have a black background. So in other words, the order in which you use your modifiers really matter. So as you can see, these two gives you two different views depending on the order in which you place these. Okay, so now if we are creating a different view every time we're adding a modifier, then what is the actual return type of our view? Well, if we look at this var body sum view, well, this body property has some kind of return type called sum view. But this thing right here, it also has a return type of sum view. But in both these examples, the actual text, remember, these things are new structs. These things are new views. They're different return types. Then how is it possible that you can give it some kind of explicit return type? I'm just going to quickly demo. You don't have to follow along. But there's this neat code that I wrote. Basically, what this does is I create a button called hello. And then if I click on the button, what it's going to do is that it's going to print out the type of this body property right here. Okay, so if I click hello, you can see that right here, this is the type of the body property. So you can see you have a modified content with a button containing some text, and then added a padding to it, and then I gave it a frame. Now let's say I change the text color, right? I could do dot foreground color or foreground style. Let's say I do dot black. So now if I run this again, and then compare the return type of this body property, I click on it, you can see that now it has this modifier called foreground style. In other words, the return type of these views are actually different. So this is where some view comes into play, right? Imagine if you have a bunch of views, right? You can have a button nested inside, or you have a text nested inside of a button. You can have all of that nested inside of another view. The return type can be very, very complex. You can see that when I added that foreground color modifier, that return type got even longer. So now imagine adding a bunch of modifiers. Every time you're doing that, a new view is getting created. So the problem is that we don't really know the actual return type of it, the view is. What we do know is that it has a return type of some view. And some view is just some kind of view that conforms to this view protocol. All right, so whenever we create apps, right, we don't just care about creating the views. We also care about positioning our views. We care about laying them out on top of each other, side by side. So in SwiftUI, to lay out your views, well, you will use another view. So one of the common views that you will be using is called an H-stack. So an H-stack, again, it's also a struct. It's a view that arranges your views in a horizontal line. So I create a view called an H-stack. If I want to put Cornell AppDev aligned horizontally, I can just put text Cornell and then text AppDev inside of this H-stack. Now this entire thing is still one view. The return type will be really, really complex. That's why we give it a return type of some view. We also have a V-stack, which allows you to arrange your views vertically. So I use a V-stack, put in two texts inside, and it gives me that kind of look right there. And then finally, we have a Z-stack that allows you to overlay one view on top of another. So if I want to have a color red underneath the text AppDev, I create a Z-stack, put color.red, and then on top of that, I put text with a view with the text AppDev in it. Now the thing is that each layout or each view can only store up to 10 views at a time. So right here, what I'm doing is that this Z-stack can only contain up to 10 views inside of here. So if we had more than 10, then what we want to do is kind of break up our code and combine it into one view. So for example, if I have a Z-stack here, if I put this in a group view, or if I put it in like a V-stack, for example, that will make it have only one view inside instead of two. And then last but not least, you have a spacer, which allows you to kind of expand your views. So this horizontal stack, or H-stack, if I want to add a space between Cornell and AppDev, I can just put the spacer element. So what it does is that it just spaces everything in between the two texts. And there are like a bunch more different stacks that you can use, different views, to kind of lay out your subviews. So I'll give a demo on how to create an app in SwiftUI. So this is the demo right here. This looks like some kind of table view or collection view that you can use. So first, we want to create this kind of cell for it. And so I do provide y'all with the starter code. It's inside of the lecture textbook right here. I'll give y'all some time to copy and paste that, or to clone that repository. So your starter code should look something like this. So now what I want to do is I'm trying to create this kind of view right here. So first, what I'm going to do is let's start with that text with the number 2 in it. Oh, you have a question? Oh yeah, so in order to use the demo code for today, unfortunately you need Xcode 15. But low-key, what you can do is actually just create a new file, a SwiftUI file, and it'll look the exact same. The only difference is that you don't have these image assets, but that you can just copy it over from like the table view or collection view lecture. And then this bird model that I have, you can just look at the repository and then just copy that code over. Okay. So first, inside of content view, I'm going to create this kind of view right here. So what I'm going to do is let's start with the text 2, or I'm going to use yeah, I'll just use me as an example. So first, let's create a text. I'll give it a number of, let's say, 7. Okay, and I don't know why my live preview, it's slow, but the text 7 should show up soon. Okay, never mind. It just wants to crash. Oh yeah, to get this canvas to show, you can do Command Option Enter. To reload the preview, you can do Command Option 7 or Command Option P. Okay, so now what I want to do is I want to make it really large, right? I want to give it a large font. So I can do dot fonts of dot, let's say a large title. So I make it really, really big. Okay, and let's say I want it to be bolded a little. So you add another modifier, dot font weight of dot bold. Okay, now what? Now I want to create this view right here. So I'm organizing these views on top of each other. So I use a VStack. So let me create a VStack containing what? Containing the text of the name and then the location. So there would be 2 text elements inside of this VStack. So I can do text, my name is Vin, where am I from? I'm from Texas. Okay. Now, surprisingly, this thing right here shouldn't actually show. I remember when I did this last semester, this thing didn't show at all. But Xcode and SwiftUI got a little bit smarter. But technically, this thing isn't allowed because you're having 2 views inside of this one view. This one view can only return one thing at a time. But right here, you're returning 2 things. And so to fix this, well, it wasn't an issue in the first place. But if I want to organize them horizontally, I would wrap this entire thing inside of an H stack. So now they're horizontal. Now I want Vin and Texas to be aligned. So inside of here, I can do alignment of dot leading. Okay. Now what? Now I want Vin to be a little bit bigger. So I'm going to give it a font weight of dot bold. Now normally whenever we have a VStack, it's kind of nice to just space things out so that we know that there's more multiple views inside of this VStack. Okay, now what? Now I want, let's say I want Texas to be a little bit bigger. So I could do dot medium. And then I want it to be italicized. I could do dot italic. So you can see that it's very, very simple to create views when using SwiftUI. And it's nice to have this live preview so that you can kind of see it update live. Now I want some spacing in between here. So I can do dot padding. Let's give it a padding on the right, right? So you do dot trailing, give it padding of, let's say, 30. So you can see to the right of this number 7, there's a trailing padding of 30. Okay. Anyways, so now what? Now I want to have this image. So to create an image, I could just do image, and then there's an image called Vin, I believe. Okay, now I want to make it a little bit smaller. So let me just do dot frame to give it a frame, a height and a width. Let's give it a height of 100 and a width of 100. The order matters actually, so you want to put width first. But you can see that it doesn't become smaller. That's because before you do this, you want to use this modifier called .resizable. That basically allows you to resize that view. Okay, now last but not least, there's actually a space in between here that pushes everything aside. So can someone tell me what view I would put to space these two elements apart? A spacer, exactly. And so right after the VStack, right before the image, I'm going to add a spacer in here. Yes.
Do you know to use a spacer versus .padding, .trailing?
Yeah, so a spacer is used if you want to like expand things all the way, and then the padding is more of like just like relative to another thing. You'll develop the intuition. It's pretty intuitive when you actually code in SwiftUI. You can actually have multiple spacers. So if I put like another spacer here, basically what's going to happen is that they're going to fight each other and then space everything in like they're kind of push with equal weight. If I put even another spacer right here as well, so two spacers here, it's going to push it even further. Yes.
So does the spacer like kind of do the same thing as like putting the image to the trailing end of the view?
Yeah, kind of, right. So yeah, it'll space it until it reaches the very, very end of the view. And that view could be even inside of another view.
So let's say you put like a padding on the trailing end of the image. Will like the spacer like override that, or will the padding like, push back on the spacer?
Yeah, the padding will actually push back because that padding is for that overall view, and that spacer will only push it out until it reaches the end of that view. Okay. So now I have a cell for it. Now what I want to do is I want to put this inside of some kind of list. Okay. So now remember we want to make our code really clean. So what I can do is just factor this out into another variable inside the struct. So I'll do private var. I can call it bird info row. It's some view. And then I'll pass this inside of here. And then I can just call it in here. All right, now that makes it a lot more simple and makes your code a lot easier to read. Now every view that you create must be inside of this var or this body property. But then you can still filter it out or factor it out and then make it look a lot more neat. Now what I'm going to do is create this kind of table view like structure. So there's actually many ways you can do this. You can use a scroll view with a for each. You can use a list. In this example, I'll use a list. So to create this list, you can just do list. It's still some kind of view. Now what you want to pass in is your array of data. So the array of data that I have is an array called birds. So what I'm going to do is I'm going to pass in birds inside of here. And then I'll put this bird info row inside of here. Now it's giving me some kind of error. Now think about it this way. When you're using a UI table view or a UI collection view, you needed this thing called an identifier or reuse identifier. The same thing applies to a list. You need to identify each element inside of this list. So this bird info row needs some kind of identifier to it to know that I guess like each bird is separate. So you can do ID, do \dots. Now these are the different properties of each element inside of birds. So birds is an array of bird objects. Doing \dot is called it's called like a key path notation, and it basically gives you like the properties of that bird object. So you can use whatever you want to identify it. The best way to do it is to use that instance itself by doing \self. Now in order to use that object itself as an identifier, you want to conform it to hashable. Okay, now this list, each element of the list or each element inside of birds will be this bird right here. So if I type in bird, you can see that, well, it doesn't show the type, but the type of this will be a bird object. So this right here represents one element inside of birds. So as you can see, birds, there should be, there's like 10 birds in here. And so what this list does is that it's creating a bird info row for each bird I have in this array. So this is just scrollable view. Now the problem is that there's a bunch of VINs, right? But I want it to be unique. I want it to have the same or different cells. So if you look at the bird object or the birds, there's different bird objects. So I want to be able to customize this bird info row in order to take in a bird object. So instead of a property inside the struct, what I can use is a function, because a function can take in some value. So I'll use private func and then give it a return type of SumView. Now, what would this bird info row take? I'll pass in some bird object. So now, when I call bird info row, I need to pass in that bird object itself. So this bird represents that bird element inside of this array, and then I can just do bird in here. Now, what I want to do is that for each text, I want to use this bird object that I passed in. So instead of 7, I can do bird.count. Instead of VIN, I can do bird.name. Instead of Texas, I'll do a bird.location. And the image, I'll do bird.image. Now, this is giving me an error, right? If you look at the type of bird.count, you can see that it's an int. But this text field, when you initialize it, it needs to be a string. What you can do is just simply cast it to a string. So as you can see, each row inside of this list is unique. Are there any questions? Yes. Yeah, so this is right here is called an external parameter. This is an internal parameter, meaning that this bird right here is used inside of this function, whereas this right here is being passed into the whenever you call it. So if I call this like for example, bird info row for some bird, here I would have to use for here. Right? You can also do like bird. In that case, you would do bird here. But that's very redundant. You could just replace with an underscore so that you can just pass in bird itself. Okay. So now, the last thing I want to do is actually factor this out into a separate file, because normally your views, your project will have multiple files. So to create a new file, right click, new file. I'm going to create a new SwiftUI view, and then I'm going to call it, I believe I called it bird list view. Create that. So now it looks just exactly like content view. But if you look at BirdWatch app, remember this is the entry point of the app. The entry point is content view. So this thing will be loaded first. So now I want to refactor my code, copy all of this, and just paste it inside of here. So now, instead of having this in here, all I have to do is just simply call this bird list view struct that I created. So bird list view here, create a struct that has this, these properties and these functions, and then I can just call it here. All right, are there any questions? All right, sounds good. So for Wednesday's lecture, we will go even in more detail and actually make our app a lot more useful. So right here now, all we're doing is just creating a static view. But a lot of the times, our app is very complex. You have logic associated with it. But remember, when you're using structs for views, every time you're changing its properties, you're creating a brand new struct. But that becomes an issue whenever you're changing your logic or defining the logic in your app. So in SwiftUI, there's a way, a declarative way to kind of modify the state of your app. And we'll discuss that in Wednesday's lecture. Yes?
So I know that SwiftUI is a little, like obviously it's easier in a sense, but it's not as advanced or specific as UI Kit as of yet. So like, can you use both in like a project, or can you only like choose one?
You can definitely use both. Honestly, like a lot of people, they come to me like, yo, SwiftUI is so easy, so much easier than UIKit. As someone who started with UIKit, I learned SwiftUI last semester when I joined AppDev. I realized that SwiftUI is very different. You think differently whenever you're creating your app, right? It's like making the views obviously is a lot easier, but then when it comes to logic, so like Wednesday's lecture, when you're dealing with logic, it's like a lot different whenever you're using UIKit. My personal recommendation is if you're creating an app, I would honestly use SwiftUI because it's a lot quicker to do and it's a lot more intuitive, and to me it's a lot more fun. But in industry though, a lot of apps right now are actually not even written in Swift. They're sometimes written in like Objective-C, so really, really old languages. So it's really, that's why we still teach it in UIKit, teach the course in UIKit, because when you go out in industry, you might be using even older frameworks. All right, any other questions? Okay, y'all are free to leave. Let me know if y'all have any questions.